Hello friends, welcome to Risingpearl.com. Today we are talking about series 7 where we are learning quadratic equations. This is webisode number 9, and friends, today we are going to continue to learn more on how do we solve equations, questions on quadratic equations. This is part 3. So part 1, part 2, part 3, part 4, friends, this is like a running parts throughout the series. In the last webisode 8 was the part 2 where we looked at some more questions on quadratic equations. So friends, let's get started. Now here we have to find out the roots of 4x squared plus 3x plus 5 equals 0. So clearly we will see that 4 times 5 is 20. 20 we can write this as 10 and 2, the two factors, or we can write this as 4 and 5. If we take 10 and 2, and they're all positive numbers, so if we take 10 and 2, so we will get, if you add them, we will get 12. If we add these, we'll get 9. So we are not going to be able to get to 3 using middle term factorization. So we have to use the completing the square method. So we have 4x squared, so we can write this as 2 square x square plus 2 times this 2 times something x. So we have 3x here. So we already have 4 over here. That means we need to divide by 4. So we get to 1. And then we have to get 3. So we put 3 here. So this is the value that we have to actually square. 3 by 4 whole square minus 3 by 4 whole square, because we added this term. So we have to subtract this term away, plus 5 equal to 0. So this is a quadratic equation. So let us just get this on the side. So what we have, friends, from here is we will have, so this is 2x plus, this is plus, so if this is plus, this will be plus, 2x plus 3 by 4 whole square, and then here we have 3 by 4 whole square plus 5. So let's get these terms on the other side of the equality sign. So minus will become plus, and 3 square will be 9, 4 square will be 16, and this plus 5 will become minus 5. Or here, this is the denominator is 1. So if you take the LCM, you will get 16. So you have 9 minus 1 16s are this. So 16 5s are 80. 16 5s are 80. Or we will get, if you solve this, you will get minus, this will be 71 by 16. So what we have, friends, is that we have 2x plus 3 by 4, this whole square. This whole square is equal to minus 71 by 16. Now at this point, friends, I want you to pause for a moment, because the next logical step is for us to do the square root on both sides, right? We do square root on both sides. But what you want to understand here is you have 2x plus 3 by 4 whole square, right? And that is equal to minus 71 by 16. In other words, you have 2x plus some number, which is 3 by 4 here. If you whole square this, you are getting a negative number, because whole square is minus 71 by 16. Now if you think about it this way, if x equals 0, you get a positive number. If x equals negative, so that this entire thing inside becomes negative, but if you do a square root of that, you will still get a positive number. If x is positive, if you do a square of that, you will get a positive number. Meaning that For no value of x can the square of this becomes a negative number. So we say, friends, here that x has no real roots or zero real roots. Roots mean, obviously roots are the solutions, right, that satisfy the equation, the quadratic equation. But for this particular quadratic equation, this is the first time that we are seeing this, is that there are no real roots, there are no real numbers that can actually satisfy this condition. Because x can be 0, this entire term will become a positive number because 3 by 4 whole square. If x is such a big negative number that the entire thing inside becomes negative, but negative to negative times negative is a positive number, that will not be negative. And if you take x as a positive number, this will still be positive. So under no real number scenario can whole square of this become negative. So we say that x, the variable x, has no real roots or zero real roots. This is important for us to understand this, friends. And then we are going to actually have a lot more on this topic later on in subsequent webisodes. Now, how about we reflect back on some of the questions that we actually asked at the very beginning in webisode 1 when we started the series of Risingpearl, this series 7, Quadratic Equations. So, John's mother is 20 years older than him. The product of their ages in years, 5 years from now, will be 800. How old are they now? So we assume that John's age, we say John's age is equal to x. Let's assume that the John is x years old. So John's mother, her current age will be, mother's age will be x plus 20 because she is 20 years older. X plus 20, this many years. We don't know what this is, but this is what is given. Now also what is given is the product of their ages in years 5 years from now. So 5 years later John will be, so after 5 years, and friends, I am actually showing you how you have to handle these kind of questions. I'm not really writing it in a nice clean way. After 5 years, John's age will be equal to, if he is x now, he will be x plus 5. This many years. And his mother, her age, mother's age will be equal to her current age. Remember that his mother, she is x plus 20 right now. So it will be x plus 20 current age plus 5. Or in other words, her age is going to be x plus 25. So John's age 5 years later, after 5 years, will be x plus 5. His mother's age will be x plus 25. So now let's give ourselves some more space. So what is given is that the product will be 800, meaning x plus 5 times x plus 25. This product is 800. And we have to find out how old are they now. So we have to actually open this up, right? We cannot, in order for us to solve this, we have to write this in a standard form of quadratic equation and then solve it. So x times x is x squared plus x times 25 is 25x plus 5 times x is plus 5x plus 5 times 25 is 125. This is equal to 800, or x square plus 25 plus 5 is 30, x square plus 30x minus 800 minus 125. So you will have 75, that will be 200, 675. This equals to 0. So we have 675. So x square plus 30x minus 675 equal to 0. So if we were to try to do middle term factorization, so we have 675. 675, this is divisible by 5. So 5 times, we can write this as 5 ones are 5. So if you were to divide this by 5, that's what we're trying to do actually, right? 675. If we divide this by 5, 5 ones are 5. 1 7, 5 threes are 15, 2 5, so 135. 135. So now 135 is, so we can write this as, so 5 times, now 135 actually is, we can actually write this as, 135 is 5 2s are 10, 27. Right? I think we did it correct. So if you divide this by 5, 5 2s are 10, 3 5, 5 7 are 35, yeah, 27. In other words, we are still trying to find, because this is such a big number, trying to find out all the right factors that will give us 30, right? So we have 5 times 5 times, this we can write this as 3 times 9. Now let's see if we can find any combination. So we are trying to get 30. So if we do if we do 25 and 27, that doesn't help, right? 25 and 27, that does not help. How about if we do 45, 9 and 5 and 9, 45, and 5 threes are 15. Yes, this actually works. 45 and 15, because we have a negative here, minus, and we have plus over here, so we can actually keep the bigger term plus and we can have minus 15. So we can actually split the middle term as x square plus 45 x minus 15x minus 675 equal to 0. So from here we can take x common, so we will get x plus 45. From here we get minus 15 common, x plus 45 equal to 0. So from here we get x plus 45 common times x minus 15 equal to 0. So the two values for x, or the two roots of this equation, this quadratic equation, the two roots are x equals minus 45 and x equals 15. Because if you take x plus 45 equals 0, then x will be minus 45. X minus 15 equals 0, x will be 15. Now remember, so now normally if this were a quadratic equation and you are solving for x, you have got the correct answer, which is minus 45 and 15. But this is something which is not a numerical quadratic equation, in the sense that what is x? X is how old is John currently, right? So John's current age is x. Now he cannot be negative 45 years old. That is not possible. So the only right answer is 15. In other words, so let's write it here. So John is 15 years old and his mother, John's mother, is 20 years plus John's age, 15 plus 20. So this will be 15 plus 20. So she is 35 years old currently. We have to find out how old are they now. So current age for John is 15, mother is 35 years old. So friends, I wanted to walk you through step by step of how you have to take the information which is given in the question, logically try to simplify that. At one point, you are going to get a quadratic equation. Then using all the techniques we have learned so far, middle term factorization, completing the square method, you have to find out the roots of the quadratic equation. And then in these kind of questions, real world questions, you have to make sure that which value makes sense and which value does not make sense. And then find out all the information that is being asked in the question. So for example, here if you would have left the answer as x equals minus 45 and 15, that would not have been fully correct. If you would have left the question as the final answer as x equals 15, that also will be partially correct, because we have to find out both their ages. So John will be 15 and mother will be 35 years old. Let's take a look at some of the other questions we have seen earlier when we started the series. Product of two consecutive positive integers is 210. So we assume that let the first positive integer equal to x. So automatically, by definition, the second integer will be, yes, you guessed it right, x plus 2, x plus 1, because it is consecutive positive integers. That means, so something like 2 and 3, right? Or 31 and 32. So if the first one is x, the second one is x plus 1. Now what is given is that the product of them is 210. That means x times x plus 1 is equal to 210. So let's solve this. So we have to solve for x basically. So now if you multiply, you will get x squared plus x times 1 is x. We bring the 210 on the left hand side, because we remember that whenever we solve quadratic equation, we want to first and foremost express the quadratic equation in a standard form. In webisode 2 we talked about how to express a quadratic equation in a standard form. So now we have to apply, we have to now basically solve and find the roots of this quadratic equation. So let's try and see if we can help take use of middle term factorization. So we have 210. It's a minus, so we have minus 210. But let's find out all the factors. So this can be written as obviously 21 times 10, right? 21 times 10, or let's see, so we can write this as 7 times 3, 21, times 5 times 2 for 10. Now here it is plus 1, meaning only 1 is the difference. So we are trying to figure out how we can do it. So what about if we take 3 and 5 together and 7 and 4 together? So 3 and 5 will be 15 and 7 and 2 will be 14, and that absolutely works. Because we have plus, so we are going to give the 15 the higher number plus, and we will give 14 the negative sign, because it is minus 210. So the way we are going to break this is x squared plus 15x minus 14x, because we want to make sure 15x minus 14x is x minus 210. This is equal to 0, or from here we take x common, so we get x plus 15 minus 14 common from here, from these two terms. So x plus 15 equal to 0, or we get basically x plus 15 times x minus 14 equal to 0. So from here we get x is equal to minus 15 and 14. So both of them are the two roots for our quadratic equation x squared plus x minus 210 equals 0. Now remember, so what is the answer of the question? Question is asking what are the two numbers? What are the two numbers? Now is it minus 15 or it is 14? Now you have to read the question very carefully. The product of the two consecutive positive integers. This is your trick word here, positive integers. So x cannot be negative. X cannot be minus 15. X has to be 14. So if the first number, which is x, is 14, then my second number, which is x plus 1, will be 15. So my two numbers are, these are my two numbers. Let's take a look at one more question, friends. So we had also looked at this question at the very beginning, right? Sum of areas of two squares, sum of areas of two squares is 468 square meter or meter square. If the difference of their perimeters is 24, what are the sides of the two squares? So we know that sum of the areas, so let's say the first square has side x. So the area will be x square, and for the second square, let's say its side is y, so its area will be y square. Sum of the areas of the two square, if you add them, that is area of first square plus area of second square, you get 468, right? Now if the difference of the perimeter, so perimeter of the first square will be how much? It will be 4x. So let us just assume that x is the first square is bigger than the second square, because it is saying the difference, meaning one is more, one is less. We don't know it is the first square which is bigger or the second square which is bigger. So let us just assume that the first square is bigger. So the perimeter of the first square is 4x minus, because that is bigger, we are assuming 4y is equal to 24. So if you focus on this particular equation, so we have like two different equations here, this and this. So if you focus on this, we can actually divide both sides of the equation by 4. So we will get x minus y equal to 24 by 4, which will be 6. Or from here we can say x is equal to y plus 6. So the y goes on the other side, y plus 6. Now why did we do this? The reason why we are trying to do this is that we want to replace x in the equation 1 by this value, so that equation 1 has only y as the variable, so we can solve for it. So in other words, so we have the first equation is x square plus y square equals 468, right? So we want to replace x, so we have x square plus y square equal to 468. So instead of x, we want to put y plus 6. Instead of x, we want to put y plus 6 whole square plus y square is equal to 468. So now friends, if we solve them, let's give ourselves some space here. So if we solve them, so what we have is we have y plus 6 whole square plus y square equal to 468. If you expand this, you will get y square. This is simply a plus b whole square, y square plus 2ab, 2 times y times 6, which will be 12y plus 6 square is 36 plus y square is equal to 468. So y square plus y square will be 2y square. It will be 2y square plus 12y plus 36. So instead of 36, let's get the 468 also on the left side. So you will have 4 minus 468 plus 36. So let's do it here. So we have 468 minus 36. So we will get 8 minus 6 is 2. Now 6 minus 3 is 3 and then 4. So this will be minus 432 equal to 0. Or all of these terms have 2 common. So let's divide by 2. So y square plus, so 12 divided by 2 will be 6y minus, if you divide this by 2 you will get 2. So we are trying to do this basically, right? So we will have 2 2s are 4, then we will have 3, 2 1s are 2, 1 2 6. So we will get 216 equal to 0. So now we have to apply middle term factorization on this quadratic equation. So finally friends, after doing all of this, we have got the quadratic equation that we have to solve to find out the value of one of the squares. So now 216, so let's write it here. So 216. So how can we break 216 so that the middle term is 6? Well, we can actually do it many different ways. So first is 6 3s are, actually it is 6 times 6 times 6, right? 216 is 6 times 36. Or we can do it at 6 times 3 times 12, trying to write the 36 as 12 times 3. So if you look at it here, so we have 18, 6 3s are 18 and 12. So this will actually work because we have 6 and 18, 12, we can get 6. So that means we are going to write it this way. So y squared, it's plus 6. So the 18 will be the plus 18y minus 12y minus 216 equals 0. So if you solve it, you will get basically y plus 18 times y minus 12 equal to 0. So the two roots are y equals minus 18 and y equals 12. Again, what is y? Y is one of the sides of a square, so it cannot be negative. So y is equal to 12. So if y is equal to 12, that means one of the sides, all the units are in meter. So if y is this much, remember that x is equal to y plus 6. So then x will be equal to y plus 6. Let's do it here. Y plus 6. Y is 12 plus 6 equal to 18 meters. So first, so the bigger square, what are the sides of the two squares? So the bigger square is 18 meter and the smaller square is 12 meter. So friends, I know that this video has gone on for a little longer than what we want, but again I wanted to take the time to explain to you how you will be solving these questions. You have to really go step by step and first formulate the quadratic equation correctly, because if you make a mistake there, then you will have the wrong quadratic equation and you cannot solve it. Once you have the right quadratic equation, then find out the roots using middle term factorization or completing the square. At that point, you have to look at the question and see which of the roots make sense, right? And then make sure all of the details that the question is asking, that you are answering each and every bit of all the aspects of the question.